Hey everyone, this is lesson 29 and it's multiplying fractions and reducing fractions by dividing by common factors. So really starting to dive into the fraction work. This is really important to get a good foundational understanding of as we move forward. So taking a look at our learning targets for today, got some big ones. We need to be able to multiply a fraction by a fraction, multiply a whole number by a fraction, reduce a fraction in one step by dividing the numerator and denominator by the GCF of the two numbers. That sounds harder than it is. And then reducing a fraction in two or more, it's supposed to say or, not that kind of an or, two or more steps by dividing the numerator and denominator by a common factor other than the GCF, and then repeating the process until the fraction's completely reduced. All of those are important in working with fractions. As we scroll on, I'm just going to zoom out a little bit here. I'm going to ask you to take a look here. We have, when we're multiplying fractions, right here, for example, they say 1/2 of 1/2. In math, I've mentioned this before, but in math, anytime you see the word of, we're talking about multiplying. It's really one of those buzzwords that means multiplying. Of means to multiply. So if we were to take 1/2 of 1/2 or 1/2 times 1/2, really, we would be like, just to give you a visual, we would be taking like half of this circle and cutting that in half. So without actually doing any math on paper, you can see that by taking 1/2 of 1/2, we end up with 1/4. 1/2 times 1/2 is going to give us 1/4. When we're doing the actual math here written out, we can see, so actually doing, working out this math, when you multiply fractions, it's way easier than adding fractions. All we're doing is multiplying across. You multiply everything. So we have 1 times 1 on top. 1 times 1 is 1 for our numerator. And on the bottom, for our denominators, we have 2 times 2, and that gives us 4. Look at that. 1/4. So here's a computational way of solving this problem, and here's just a visual way of taking a look. Same answer. What fraction is 1/2 of 3/4? Please remember, the word of means to multiply. So what is 1/2 times 3/4 or of 3/4? Please pause your video, give this a try, and unpause when you're ready to check your work. Okay, so you can see that I've worked out this problem. First of all, I just rewrote this problem. Instead of the word of, I've included a multiplication sign. For our numerators, we have 1 times 3, and we get 3 on top for our numerator. And on the bottom here for our denominator, we have 2 times 4, and we get 8. Looking at this answer, before I decide that I'm done, I always stop and ask, can I reduce this at all? And then I see 3 is our numerator, 3 is a prime number, and the answer is no. That answer is complete. 3/8. Multiply 3/4 times 2/3. Again, please pause the video, give this a try on your own, and unpause when you're ready to check your work with mine. I'm not even going to pause my video. I'm just going to start working right away. I'm going to multiply across. 3 times 2 gives us 6. 4 times 3 gives me 12. 6/12. Now, like every other fraction, I'm going to stop and ask myself, can I reduce this? Because right now, this answer is not wrong, but it is not complete. So really, really important as you move forward with your math, always, anytime you're doing work with fractions, actually this applies to ratios as well, but anytime you're working with fractions, you always assume that you need to reduce it into simplest form. Always. So 6/12, that's a really easy fraction for me to identify. 6 is half of 12. Anytime your numerator is half of what the denominator is, your fraction is 1/2. So I know that 6 is half of 12. I know that both of these numbers are divisible by 6. So if we're really going to break this down, we're finding common factors. 6 is a factor of 6. 6 is also a factor of 12. So if I am to divide the numerator and the denominator in this case, both by 6, I end up with a beautiful reduced fraction of 6 divided by 6 is 1. 12 divided by 6 is 2. Look at that. 1 half. All right. Shortcut. I wonder, I'm not positive about this, but I'm going to use this opportunity to show you something. This is called cross-reducing. Cross-reducing doesn't necessarily seem like it might apply in a situation like this where our numbers or our digits that we're working with aren't very high. But I'll tell you what, when you start multiplying fractions with very large digits, I'm going to use this opportunity to talk to you about cross-reducing. So basically, you're going to look at a diagonal. When you're looking at when you're multiplying fractions like this, you're going to look at a diagonal, meaning across like this. So we're going to look at our 3 and our 3 and our 4 and our 2. And we're going to look at how we can reduce these numbers ahead of time to simplify our multiplication. Again, doesn't totally make sense to do it with such small numbers right now. But seriously, as you advance in your math, sometimes these numbers will look like 120 or whatever, and it'll really reduce your work time and brain space as you're doing this math. So looking across at this 3 and the 3, is there anything that we can pull out of those numbers? Can we reduce these 3 and the 3 to make our math simpler? And the answer is definitely. When the number is the same thing, they have a common factor. That common factor is 3. So 3 can go into 3 one time. 3 can go into 3 one time. We've divided each of those numbers by a common factor of 3. Now that we've done those, 1 is the simplest number we can get to. Let's go at this other diagonal. Let's look at the 4 and the 2. Do they have a common factor that we can divide out to make those numbers smaller or simpler before we do our math? The answer, of course, is yes. So we have a 4 and a 2. What common factor do they have? They both have 2 in common. One error that I see sometimes is that people will say that they both have a 4 because 2 can go into 4, but that doesn't work because 4 is not a factor of 2. 4 does not go into 2. You have to choose the smaller one, if that makes sense. So 2 can go into 2 and 2 can go into 4. 2 divided by 2 is 1. 4 divided by 2 is 2. There we go. We've cross-reduced. Now we're ready to multiply across with our new numbers that we've formed. This will call for much simpler math. 1 times 1 on top is 1 for a numerator, and on the bottom we have 2 times 1 is 2 for our denominator, 1 half. These are 2 different methods on how to solve. This way and this way, both are appropriate. Both work. Whatever works for you is the right way. Now, moving forward, we're going to be multiplying a whole number times a fraction or a fractional part of a number. Before I even ask you to pause and try this, if that's something that you'd like to do, please do that. I typically like to walk through an example first and then have you try one. So pause the video now if you'd like to. I'm just going to start rolling with how to solve this. The first thing you need to consider anytime they ask you to multiply a whole number by a fraction is just remembering that any whole number is in fact a fraction. It can automatically be a fraction in one simple step. 4 is the same thing as 4 over 1. Same exact thing. We haven't changed the number. It's the same thing. So 4 can be written, oh, that didn't work, as 4 over 1. We're just going to bring down the rest of our problem, times 2/3. Now we can multiply across. I can tell already at first glance there is nothing that I can cross reduce to make my work simpler. I'm just going to multiply across. We have 4 times 2 is 8. 1 times 3 is 3. We have 8/3 as our answer. This is not a wrong answer, but it's definitely not complete. So keeping in mind, when I say that anytime you have a fraction as an answer, you must reduce it into simplest form for a complete answer. And that also applies when it comes to improper fractions. That's what this is called right here. 8/3 is an improper fraction because the numerator is greater than the denominator. And it's just not the most advanced way to leave your answer like that. Maybe in the beginning, as you begin your fraction work, it's okay to leave your answer like that, but We're beyond that. I want you to write it in a more advanced way. So the way we do that, anytime you are left with an improper fraction, is to convert that into a mixed number now. And to do that, we're going to think about it like this: 8 divided by 3, or how many 3's fit into 8? Well, 3 times 3 is 9. That's too much. But 3 times 2 is 6. That would work. So my whole number part is going to be 2. 6. I'm at 6 now. 6, but I need to get to 8. 6, 7, 8. I have 2 left over. My denominator stays the same. 2 and 2/3. Okay. Lots of examples in today's lesson. 3 pennies are placed side by side as shown below. The diameter of 1 penny is 3/4 of an inch. How long is the row of pennies? Basically, what they're asking us to do here is to take 3/4 times 3, right? So 3/4 times 3, just so I don't have to write this twice. I'm going to stop and think right now. Instead of writing a big 3, 3/4 times 3, I know that any whole number can be written as a fraction. I just write it over 1. 3 over 1. 3/4 times 3, okay? Again, I'm looking to see if I can cross reduce, and I can't. I'm just going to multiply across. 3 times 3 is 9. 4 times 1 is 4. Same exact scenario as before. We end up with an improper fraction. This answer isn't wrong, but it's not in simplest form. We need to convert it into a mixed number. How many 4's fit into 9? 2. 4 times 2 is 8. 4 times 2 is 8. When I think 8, 9. 9. I have one more left over. So that becomes our numerator. Our denominator stays the same. 2 and 1/4. What was my label? Let's go up and read this again. How long is this row of pennies? We're talking about inches. Okay, 2 and 1/4 inches. Okay. Reducing fractions by dividing by common factors. So looking back at this fraction of 6/12, when I walked through reducing this earlier, I modeled that I noticed that they can both be divisible by 6. 6 is in fact their greatest common factor, but just for the sake of showing you how to reduce this, if you weren't automatically able to identify the fact that they both have 6 in common, I want you to be able to identify just one common factor that they might have, because that works as well. You can just reduce them by a common factor and repeat the process until you get to the simplest form of your answer. So one thing that I notice right off the bat when I'm looking at 6 and 12 is that they're both even numbers. Anytime your numerator and denominator are both even, you can always divide by 2. So if I divide my numerator and my denominator, I don't know why I draw these at such a weird little angle, but it's just how I see it in my head. If I divide 6 by 2, 6 divided by 2 gives me 3. If I divide 12 by 2, 12 divided by 2 is 6. So now I'm at a fraction of 3/6. My fraction is not yet complete. I can continue to reduce this. It's not wrong, but it's not complete. So now I start looking, 3 and 6, they're not both even. I can't divide by 2 again, but they do in fact have another common factor. 3 is divisible by 3, and 6 is divisible by 3. So my next step is to divide my numerator and denominator both by 3. When I take 3 divided by 3, I get 1. 6 divided by 3 is 2. And after a 3-step process, I now have my answer of 1/2. So again, these numbers are really simple to begin with, but I just want to model to you that if you aren't off the bat able to identify what the greatest common factor is, identifying any common factors will eventually get you there. Reduce 8/12. Go ahead and pause this video, give it a try, and unpause when you're ready to watch me solve. 8 over 12. So I know that 8 and 12 both are divisible by 4. I'm going to start with 4. Whatever I do to the numerator, I do to the denominator, and vice versa. So 8 divided by 4 is 2. 12 divided by 4 is 3. I'm left with 2/3, and I stop and ask if I can reduce that any further. Those, in fact, are both prime numbers. I can't reduce those any further. 2/3 it is. Here again, practicing multiplying a whole number times a fraction. I'm just going to rewrite this. Whole numbers can always be written as a fraction. All you have to do is put a 1 underneath. There are a lot of practice problems in this lesson. Nothing wrong with lots of extra practice, though, especially when it comes to fraction work. Working with fractions is like traumatizing for a lot of people, and they don't need to be so scary. We have 2, or 2 over 1, times 8/12. I'm going to look right away. Not that I can't do multiples of 12, but just to save me some easier math, make it for easier math, I'm going to look and see if I can cross-reduce it all. So looking here first at my 1 and my 8, if one of my numbers is 1, I never can reduce further than that. So that's untouchable. I can't do anything with those. But if I look at my 2 and my 12, I definitely can reduce some there. So those are both even numbers. I can divide them both by 2. So 2 can be divided by 2, and that's 1. And 12 can be divided by 2, and that's 6. All right, so that makes for some easier multiplication. 1 times 8 is 8. 1 times 6 is 6. 8/6. This answer isn't wrong, but it's not complete. It's an improper fraction, so we're not done. 6 can go into 8 once. 6, I'm not in the camera. 7, 8, so we have 2 left over. 1 and 2, your denominator stays the same. 6ths. Again, we stop and ask ourselves if we can reduce this any further. 1 and 2/6, 2/6 is not complete. That can be reduced. Our whole number stays the same, but 2/6 can be reduced. Those are both even numbers and can be divided by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. 1 and 1/3 is our final answer. Lots of steps in that one. Last example of the day. Example 7. There were 8 boys and 12 girls in class. Oh, I mentioned ratios earlier. Ratios and fractions are so similar. Okay. There were 8 boys and 12 girls in a class. What is the ratio of boys to girls in the class? There are many ways to write ratios. Of course, because we're working with fractions today, I feel the need to write this as a fraction. So I typically like to do the thing where you write the number, do a colon, and then write the other number. But for the sake of fractions today, I won't. 8 boys to 12 girls. What is the ratio of boys to girls? They're asking about boys first. That becomes our numerator. Taking a look at this ratio, or what appears to be a fraction, we must reduce it, always. 8 and 12, they definitely have some common factors. I know that they're both even, so they can both be divisible, but they're both divisible by 2, but I also know that they're both divisible by 4. So 8 divide, I better write that, just for the sake of notes. 8 divided by 4 is 2. 12 divided by 4 is 3. Both prime numbers, 2/3 is my final answer. Okay, couple things to take away from today. Multiplying fractions, you literally just work your way across. You work your way across, you multiply everything, multiply the numerators, multiply the denominators, and then before you finalize your answer, you always stop to ask if you can reduce that answer by thinking about what factors that those numbers would have.